So x cubed minus 9x plus 6. So x cubed minus 9x plus 6 equals 0. That's number 1. Now, notice they tell me on this one to go ahead and solve it with my graphing calculator. But let's solve it by hand first. Well, we'd like to do them without the graphing calculator whenever we can, and then we'll use graphing calculator when we have to. So go ahead. Let me give you a minute first off. Go ahead. I'll give you a little bit more time here.
I hate factoring.
Solve that one however you want, whichever method you want, by hand. Just regular. Go ahead and solve that thing. Give you a second. Who's got a method? A hush falls over the crowd, huh? You got a method to get x alone, right? X alone. So we're going to get x alone, no x's anywhere else. That's what it means to solve, right?
Oh, I did some different things.
So what'd you do?
I get like x, like they have a common or something like that.
Okay, sure.
That the x squared minus 9.
Take out an x, you mean?
Mm-hmm.
X squared minus 9 like that?
Yeah.
Plus 6 equals 0.
6.
Okay.
So right now I get an x squared minus 9 and the x plus 6 and then the x minus 3, plus 3.
Okay, yeah, factor this x plus 3, x minus 3. Good job. Good, you have some good factoring skills. Very good.
Mm-hmm. So x parenthesis x plus 6, 1 like inside of.
Like that?
Yeah.
And then what?
Then the x plus 3, x minus 3, and I did like all of them equal to 0.
Okay, are you telling me this equals that?
No. I mean all of them, like x plus 6 is equal to 0.
You're telling me the next step. You're saying you mean you went? Let me see if I understand you right. You mean you went from here? What was your? I'm asking you. From here? What was your next step? You're saying you took x plus 6 equals 0, x plus 3 equals 0, x minus 3 equals 0, like that.
Mm-hmm.
Yeah.
That's not true, right? So think about the 0 thing. Let's be super clear in our mind. When can we do that 0 thing? You remember from algebra? Yeah. Remember from here? Let me make one up real quick. X squared minus 5x plus 6 equals 0. Let's do this real quick. Do you remember how to solve that? This would be a good thing for me to remind you of. How do you solve x squared equations? Let's review that real quick. Because it's not just silliness. Write it down. We're going to use it in the end of the section. We have to actually do this. So I'm not just fooling around. It's important. So solving x squared. Let's remind ourselves because there are some at the very end of the section. So how do you solve x squared? First, step 1, get a 0. Got to get a 0. And step 2, you try to factor, if you can. Not everything factors. And or if it doesn't factor, do you remember you can use the quadratic? Yeah. Negative b plus or minus square root of b squared minus 4ac all over 2a. Right. So write that down. Put that on your 3x5 card. You get 3x5 card in the test next. Test is 3 weeks from today, I think, right, on the schedule? 3 weeks from today, September 6th, I think it is our exam number 1. And so you're going to definitely want that, where a bunch of x squared equations will solve. So yeah, that's the game plan for solving x squared. Step 1, get a 0, try to factor, or if it can't be factored, just use the quadratic formula. Let's do that on this one. So step 1, we already got the 0. Step 1's done. Step 2, factor. Remember how to factor? A little bit. Remember some of the factoring. There's a million ways. I don't care how you do it. You're looking for two numbers that multiply to be 6, add to be minus 5. Some people do the diamond. I think it's kind of nice. Multiply to be 6, add to be minus 5. So what times what is 6? What two numbers multiply to be 6?
2 and 3.
3 and 2, 2 and 3. Either order doesn't matter. But the signs matter. How do they add to be negative 5? Both negative, right? Minus 3 and minus 2 make negative 5. Add two negatives multiply to be positive 6, don't they? So that's my pair. It's going to be x minus 3, x minus 2. So far, so good? Mm-hmm. If I FOILed that out, first to both, second to both thing, it would go back to this, wouldn't it?
Yes.
It's the same. Yes. It's true. Okay, so now where do you go from here? Now, here's the point we were talking about. What do we do next? What is our next step? This is where Abdul, right? Abdul was saying you set each one to 0. So set this one to 0, set this one to 0. Is that true? Yes. Can I go from 1 equals 0 to 2 equals 0s like that?
Yeah.
Why is that true?
Because one of them should be like 0.
How do we know one of them should be
I don't
0?
know, that's why I put it.
Why is that true, Rebecca?
Because if you're multiplying, one of them has to be 0 because you're multiplying something by 0 to get 0.
Yeah.
You get 0 when you multiply.
Exactly. Just what if I said, hey, guys and gals, I'm thinking of 2 numbers in my head. Okay, I am. I'm thinking of 2 numbers in my head, and I'm timesing them, multiplying them, timesing them, it's coming out 0.
One of them's got to be 0.
If I'm thinking of 2 numbers in my head that multiply to be 0, what do you know?
One has to be 0.
Yeah, either the first one could be 0, because 0 times anything would be 0. Or the second one could be 0, because anything times 0 would be 0, right? If I'm timesing 2 things coming out 0, either one could be 0 to make it true. Well, that's what this is saying. Are you speaking equation? He's talking to you. Are you speaking his language? He's saying something times something, right? Parentheses, multiply. Something times something equals 0. Like me saying I'm thinking of 2 numbers. So that first one is 0 or that second one is 0 because they times to be 0. That's just logically, reasonably what it must mean. Right, so Abdul's right on the money. Move that 3 over, move that 2 over. Positive 3, positive 2, done. That's how you solve when they factor. We're going to have harder ones at the end of the hour that don't factor. In that case, use the quadratic formula. This is for solving any x squared, isn't it? See, that was for up here, solving x squared?
Yeah, any x squared.
Any x squared.
We're working with an x to...
We'll get there. Yeah, but so I just want to remind you, make it clear in your mind, that's x squared. That's for solving any x squared if you can't factor. You can factor or you can do the quadratic formula. All right. Now, what if I told you, hey, let's try the same reasoning. I'm thinking of 2 numbers in my head, and I subtract them. Not times them. Subtract them, and it's 0. Does that mean they're both 0 or one of them 0?
One has to be negative.
Not at all, right? If I'm thinking of 2 numbers and I subtract them, it could be 5 and negative 5. No. 5 and 5. That'd be the same number, huh? 5 and 5, 3 and 3, 2 and 2. It doesn't mean one of them is 0. That logic only flies for times, right? Only if you're timesing 2 things and it's 0. Does that mean one or the other is 0, right? So that's my issue here. This does not mean that. Why not? They're times, and then he's what?
Oh.
Adding 6. That's wrecking the whole thing. That's my. I always crack up with that terminology. My 14-year-old son's wrecked you, Dad. I know people. The new talk just.
My son.
Because it feels like, what do you mean you wrecked? Like you took my car and wrecked it? This is what I always think. So I always say it back to him in various ways, and because it cracks me up. So anyway, so that wrecks it, doesn't it? That wrecks the logic. If that plus 6 wasn't there, then yeah. Then if it was just things multiplied, then one of them would have to be 0. But not with plus 6, right? If I said, hey, I multiplied a bunch of things, then I added 6, and it's 0. Well, whatever. I don't know anything. I can't do anything with that. That doesn't mean anything. It doesn't mean that this guy's 0 or that guy's 0. Not necessarily, right? Just because I'm timesing some things and then adding 6, and it's coming out 0, doesn't mean those guys are 0. In fact, these guys must be negative 6 is what it really means. Because you add 6 and you get 0. Anyway, we can't do the 0 logic. That's just not true. So one last try. Does anybody have a method to get x alone here?
Could you subtract 6 over before you do all that step and then still have that?
Okay, we'll try that. By the way, nothing's going to work, but I'm letting you play around for a little bit. Nothing's going to work. But I want you to see it and feel it. So yeah, if you move that 6 over, it's negative 6. I'm already feeling it. Are you feeling it?
Yeah.
This problem is reckoness. Sorry, I just like that terminology. All right, so you move that 6 over, it's negative 6. Now what? Where are we going?
I can do the factoring again.
Sure, the x minus 3, x plus 3, like that. Okay. That was a good job factoring. Now what, though? Hey, I know. You can tell I'm just be goofy by that tone, huh? Each one is negative 6. No, that logic only flies for 0. If I said, hey, I'm thinking of numbers that times to be negative 6. So what? It doesn't mean they're negative. It could be 2 times negative 3. It could be lots of things, right? That logic only flies for timesing to be 0. It's the only time it's true.
Are we going to make a u?
All right, so this can't be solved, at least by us, right? Me included. I'm not like above you saying, you poor students. I can't solve it either. I got a master's in math. I can't solve it. It's really hard. It's super hard. Now, is there a solution? Can some people that are smarter than all of us and know math better solve it? yes, actually this one can be solved. Let me get a fresh screen here. So we're looking at, what is it, x cubed wrong problem. Minus 9x plus 6 equals 0. Minus 9x plus 6. Can it be solved? Well, now the problem is it's x cubed, right? What if it was just x squared?
That'd be better.
Yes.
Then we could solve it, the quadratic, the factor, actually that one wouldn't factor, but we could do the quadratic formula, right? Negative b plus or minus square root of b squared minus 4ac all over 2a. Yeah, that'll solve any x squared. If it was just x squared, we could do it. We can do any x squared with the quadratic formula. But it's x cubed. Is there a formula for x cubed? Yes, it's actually called the cubic formula. There is a formula that exists called the cubic. It's like this, but way harder, like crazy hard. I've seen it online, and it just confuses me. It looks bizarre and has strange symbols everywhere, which I never did anything with all the way through my master's. I have no idea. Now, what if it was x to the fourth? Is there a formula for solving x to the fourth? Yes is the answer. It's called the Quartic Formula. There's a Quartic Formula, and I haven't ever seen it, but I've read that it's even horribly worse than the cubed one. Anyway, and on you go, right? Is there an x to the fifth formula? What would it be called if it's x to the fifth? Not the penta. I guess they could. I don't know why we do 5 that way sometimes. And what's the other way you do 5? Penta or, yeah.
I don't know.
No, you said it.
No, that's 6 hexa. Quint.
Quintic.
Quintic.
Anyway, no. And this is my real point. This is where I really want to get to. Did you know that it stops at 4? There is no formula for the fifth power and beyond. And I mean what I say there. Hold on. Think about what I just said. Let me say it more this way. No, there is no fifth formula, and there never will be. Now that's a stronger statement, isn't it?
Yeah.
Not just that we don't have one currently and we're still looking. No. The search stopped in the 1800s when Mr. Galois proved no such thing could ever exist. Isn't that bizarre that we can prove that? Let me show you. I found an article while you were not solving that problem. Is it? Oh, it's not.
Each x represents a point on a plane.
Oh, Douglas, is it because the reason of because is crazy beyond me, for sure. It's the because is 100 pages of crazy complex proof. The because is well beyond us. So the because is deep and profound. So anyway, I'm not going to read all this to you, but I just went onto Google and typed in Galois. I'll just keep it real quick here. So basically, first off, the quadratic, there's the one you're used to, right, for solving x squared. This, you know how long we've had that for?
2,500 years.
This, was known by the ancient Greeks.
They use this?
Yeah, I mean, not like every ancient Greek, but some of the math science Greeks had it. Yeah, it wasn't commonly taught in public education, but yeah, there were people in that time. They had it. It's been around for a long. I always think it's funny. I mean, it's sort of funny, sort of criminal that they come out with with math books in every book, right? They come out with a new edition every 3 years. Have you seen that?
Yeah.
All the math we're doing has been around for this has been around for more than 1,000 years. Why do they need to do a new edition every 3 years? Money. I was when I was a brand new teacher, and I didn't know about that, and they first changed the edition the first time I was using a book, and I was like, oh, why is there, I like the other. I called up the publisher and said, hey, I'm good with the old edition. I don't, and the publisher's like, well, sir, we're not going to print the old edition. You can't order it for your students. I'm like, I can't? Like, nope, we're only printing the new one, and then I learned, oh, this is business.
It's a racket.
It's a racket, and it's a real racket. They're making money. Ever since then, that's why I've tried to minimize. Anyway, getting off topic here. So this has been around for long, since the Greeks, okay? And then the cubic, they come in here and they talk about, where was it? Oh, there it is. And solutions to the general cubic and quartic, that's what I was just showing you, were discovered in the 16th century. That's the 1500s. Early in that's been around for, 600 years, right? Those have been around, even though I still don't know it, and you don't know it, right? Something crazy hard. Those have been around. Then the search was on, after solutions by radical were discovered for cubic and quartic, it was assumed that such solutions could be found for degree n, for any natural number n. The next obvious step then was to find a solution by radicals to the general fifth. So they said, let's find the fifth. The quartic. No, I mean the quintic, right? The quintic, yeah, there it is. The answer to this problem continued to elude mathematicians until 1824, 300 years, 1500s to 1800s. Niels Abel showed that there existed quintics which did not have a solution by radicals. During that time, during the time Abel was working in Norway on this problem in the early 18th century, Everest Galois, there he is, was also investigating solutions to polynomials in France. Galois, who died at the age of 20 in a duel in 1832, actually found the answer. Then he died and didn't get credit. So I just wanted to give you that. I thought it was interesting history. Galois proved it at 20 years of age, which is phenomenal. They were looking at that for 300 years, right? From the 1500s to 1800s. They were looking for the fifth. They'd found the second degree, third degree, fourth degree formulas, and they were trying to find the fifth, and it just couldn't get their hands on it. And they started to suspect maybe it was impossible, but nobody had proven it was impossible. You know, they don't just say, when they say impossible, they don't just mean, hey, it's really hard and we haven't found it yet. No, they prove it's impossible with mathematical logic. That's what which is super hard. That's what Galois did. So he was only 20 years old, and he proved it. He was a genius kid. He proved it, but he was a nobody because he was only 20. So when he proved it, here's the trick. You can have something right, but not get credit for it because you don't have a name to go with it yet. So Galois was only 20. He proved it. Super hard math. I've never seen it. My very last class in my master's degree was Galois Theory, and I just did the basic baby beginning of Galois. I couldn't understand his proof. No way. It'd be crazy beyond me. Super hard stuff. He proved it at 20 years of age, 100-page proof. Nobody believed him, right? Because nobody's going to take the time. It takes, even the great mathematicians, it would take, days and weeks to read through carefully a 100-page proof with complex math. And nobody thought he really had it. They thought they'd read halfway through and find a mistake he made. And they'd go, look, you blew it here. Don't bug me anymore, kid. They assumed that he'd messed up. So nobody would read it. He mailed it to the big shot of the day, which was Carl Friedrich Gauss. I don't know if you heard that name. Gauss is one of the 5 best math science people ever in history. He was the big shot of the day. He mailed it to Gauss. Gauss was professor somewhere. And Gauss got it in the mail and put it on the shelf. He wasn't going to read it either. Everybody mailed their stuff to Gauss. He didn't have time for a 20-year-old kid's paper. He just stuck it on the shelf. So anyway, Galois started cruising around to the science fairs in Europe, trying to show the people, because he's like, nobody will believe I did it. So he started cruising around and showing people his proof at the fairs. He'd get them to read a little bit. He's trying to make everybody aware he's done it. And then he died in the duel. And after he died, Gauss took it off the shelf, read it, and went, he did it. He proved it. So he got credit posthumously after death. Galois proved it. All right, so why am I saying all that? We'll always need this. That's what it means. Do you get the conclusion? We will never. Part of what I want to do in this class is not just, you're never going to use a graphing calculator outside this class, right? I mean, what's this? We just had a math department meeting last week at the beginning of the semester. Somebody brought that up. They're like, why are we doing graphing calculators? This is like old technology, right? Nobody uses this. I mean, maybe a couple people do. They use computers, right? And they use all those fancy stuff that's on computers, Desmos and all the other Mathematica, all the great stuff that's out there. Well, yeah, that's true, but they're free at the library. It's a quick, convenient way. You'll still learn the spirit and the general procedure for learning how technology works with math and science. How do you use technology in the world? I mean, generally, how do they work together? That's what we're looking at, and here's our first lesson. That is, we need technology, and we'll never stop needing technology. It's been proven there's no 5th degree formula, and there never will be. There never will be, 5th or beyond. So therefore, in real life, when engineers and scientists have a 5th degree thing or bigger, 6th, 7th, 8th, whatever, that they're trying to solve to build a bridge or do some kind of biological thing or chemical thing, physical thing, what do? They use technology. They use computers. Really, they don't use graphic calculators. They use computer programs to give them approximate answers. So do you realize all the answers we get for these are just close? They're not exact. We are unable to get exact answers. And we always will be. That's what that means. But we have really good approximation methods, which is exactly what we're going to do if I stop this spiel and get going here with our calculator. So let's do it now. With that said, let's use your calculators. You guys have your calculator, right?
Yes.
Let's solve these things. Maybe you have. If you don't, just write down the steps. I'll write them out for you. Minus 9x plus 6. So we will always need the help of technology. All right, so here's how we do it. We're going to do it on our graphing calculator. I'll write out the steps, and then I'll actually put my calculator on the big screen and show you. So here we go. So first thing is you let y1 be the left side, x, and then the power button on your graphing calculator is the up arrow, the up caret, x to the third minus 9x plus 6, and then you let y2 be 0. That's on the y equals screen that you get by hitting the y equals button. So hit the y equals button, and you'll get there. There's a y equals button in the upper left, very upper left. If you have the TI with you, grab it. The upper left has a y equals button up there. And that'll get you started. And then you enter y1 as x cubed minus 9x plus 6. So you let the left side be y1, and the right side be y2. Okay, and then next step. So after you got that in, then you want to adjust your window. You want to make the x min negative 10, x max regular 10, y min. And that's just, why are we doing this? It's just a good starting point. There's nothing magical about it. You can do different numbers. But we just have to have a reasonably good window to get us going. Negative 10, positive 10, negative 10, positive 10.
I don't have a carrot.
So, carrots to the right, on the right edge. So, good there. So you set your window, and then you hit the graph button. Once you hit the graph button, you'll see the graph. So let's try that. Right, the y-intercept does not matter.
Okay, so when I'm in a window, it won't let me...
I'll cruise around in a minute and help people individually. Let me get the basic instructions down for everybody first. So we graph it. So you go ahead and get your window, get your graph, and now we do what? What do we do? Oh, we do find the intersection. So now, how do you find the intersection points? You can't just move your cursor around. A lot of people make that mistake because if you move with the arrows, you move around. You might think that's working. It doesn't work. It'll be close but not right. So you have to do this actual routine I'm going to show you. You hit second and the trace button, because above the trace button is calc. You're really going into the calculation mode to calculate things. And then you go all the way down to is it intersection or intersects or something? What is it? Intersect. It just says intersect. Go down to intersect and hit enter. So second, trace, which is really calculate. Go down to the intersect option, hit enter. And then move your cursor close to the first intersection point. Move your cursor close to the first intersection point, and then hit enter, enter, enter. I'm doing it a little different than you'll see on Math Excel. Click the help button. They'll show you a different way using the 0 function. Probably if you go on YouTube, you'll see that as well. And that way's okay. I found this is a little easier for students this way over the years. 3 times, and you'll have it. So I'll show you in just a second. Question?
The y2, put it equal to 0.
Mm-hmm.
Just wondering why.
Yeah, that's the right side. So think about, good question. Let's talk about why is this true. We're trying to solve that equation, right? We're trying to find where the left side equals the right side. So that'll be where the two graphs hit each other. Because where they hit, they're equal. Does that make sense? Where they intersect, they are equal. And the second graph, in this case, is just 0. So where this thing hits 0, they are equal. So finding the intersection points finds where they are equal, which is what we're trying to do. We're trying to solve that equation on that.
So later on, as we get into the questions, the 0 won't be a 0.
It won't be a 0. It'll be some other equation. And I'll have another curve up here, and I'll want to find where they hit each other, not just where it's on the x-axis. Because in this case, the second one is just the x-axis, huh? But it won't always be that way. We'll see. We'll do another one. All right, so let's do it on the calculator now. So having done all that, you'll get, let me just draw the graph here again. So the graph looks like this. And we got this answer, this answer, this answer. And this one is, and they want you to round to 2 places. So minus 3.29, that'll round to be. And this one will be 0.71, 2 places. And this one is 2.58. So just want you to type in those 3 answers, any order, doesn't matter. Those are the 3 approximate answers to the original equation. That's how we do it in the real world when they do things with math and science. Oh, sorry, I didn't know you weren't on the screen the whole time. There it is. There. That's what we just did, right? So there's the 3 answers that we just found. Is that good? Yeah.
No significant figures, so it's like 3, 2, and 3.
Significant figures are something in physics or chemistry where you use a measuring tool. And it's only so accurate, so you can only rely on so many digits. That's not what we're doing here. They're giving me an exact equation, so I don't. Yeah, I just go to how many decimal places they're saying. They're saying go to 2 decimal places. So I just go to 2 decimal places.
I don't
on
know
that.
what I did.
Is that good? Let's try. I've already got the answers there for you. So let y1 be the left side there. y1 be the left side, which is this. And let y2 be the right side, which is that. Then go through those steps, you know. Let me write the. So this time what we get, let me draw it out. This time what we get, the first one goes, okay, it's kind of hard to tell. It goes up, and then down, and then back up and down, kind of like that. And then the second graph comes in and goes boom, hits over here, kind of comes up here, boom, and goes boom, boom, like that, right? So they hit here, 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 and here, don't they? 4 places they are equal. That's what we're trying to solve, right? Remember, what was the original equation? Where does this equal that? Well, wherever they intersect. Wherever y1 and y2 hit each other, that's where they're equal, right? Now, I just want the x values. I don't care about the y. I just want the x. So now we go on and we say, okay, let's find it for, and here's the answers. It doesn't matter what order you write these in. Any order is fine. Those are the 4 x answers, approximate solutions. We got 3 minutes. I need those 3 minutes. I got to do something else. By hand stuff. Yeah, remember how to solve with fractions by hand? What do we do? Yeah, this is all by hand stuff now. Yeah, multiply through. What's the common denominator? 10. So you multiply through by 10, 10, 10, and then what do we do?
2x.
Cross cancel, right? 5 into 10 2 times, 2 into 10 5 times. Then bring it over here. 2 parentheses x plus 5, 5 parentheses x plus 4, 4 times 10. Is everybody tracking with me on that? So then that 2, am I going too quick? That first step is the big one. You can all get it after the first step, huh? So I'm going to move on to another problem real quick. But is everybody okay with that?
It's
first
gonna
step?
be. It's gonna be like. It's gonna be 2 times x.
Exactly.
times
You know
5.
the rest.
Okay.
Everybody okay with that first step, though? So I multiplied through by 10. And everybody see the cross canceling? Everybody good with that? All right. Okay, what do you do on this one? 3x squared. 10x, but remember I wrote the instructions for x squared with an equal sign earlier. Step 1 is, get a 0, remember? Step 2 is you try to factor. And if you don't want to factor or it won't factor, you could do the quadratic. Negative b plus or minus the square root of b squared minus
But it's always
4ac
gonna be plus or minus.
all over 2a. Remember that? So step 1 would be to jump these guys over and get a 0. So 3x squared minus 10x minus 8 is 0. You can just plug into the quad if you're not wanting to factor. A is 3, B is negative 10, C is negative 8. Just stick them in the
But
quad.
when it says negative b and it's a negative number, it's gonna be positive.
Of course, you know all those
Does
details.
it matter if you subtract the 3x squared over instead?
It does. That's okay too. Yeah. It's harder to factor with the front being negative. But if you're just going to go to the quad, it doesn't really matter. It's all good. Oh, I wish there's number 14, super hard to factor. You're going to have to look at YouTube because we're at it.